Okay, this is Edexcel June 24, further maths, core pure 1 paper, and it's question 7. It's a vectors question. Right, so starts off with these two lines, L1 and L2. You'll notice we don't know the full coefficients for L2, there's a P there. And the plane pi contains both L1 and L2, so both these lines sit on the plane. So these directional parts here will be the directional parts of the plane. We need to show that the vector 3i minus 10j minus k is perpendicular to the plane, to pi. Well, there's a couple of ways we can do this. So basically, because these are the two directional parts of the plane, because you can remember you can write the equation of a plane with just a point on the plane and then two directional parts, and these two, because both these lines are on the plane and these aren't parallel at all, they're different directions. Those can be our directional parts. So therefore, if we're looking for this to be perpendicular to the plane, it has to be perpendicular to these two directional parts. So we can just dot these two together, dot product, that with that, and that with that, and both of those dot products should give us 0, if it works. So that's way number one. Second way is, because these are both the directional parts of the plane, if you do the cross product of them, you should get a vector that is perpendicular to them. Well, if this is perpendicular to the plane, that means our answer when we cross those two vectors together and get the cross product should be in that direction. And so all we need to do is show that the cross product of these two gives us a vector that is parallel to that. Now, not everybody does the cross product. And so if you've never done the cross product, I really highly recommend it. It is without a doubt the easiest way of finding perpendicular vectors. However, I will do it the way I imagine, because it's not on the specification of the cross product. I will do it the way that I imagine that Edexcel would like us to do, which is that dotted with that equals 0 and that dotted with that equals 0. So I'm just going to use column vectors if that's all right, just very quickly. So 3 minus 10 minus 1 dotted with 2, 1 minus 4 gives me 6 minus 10 plus 4. Oh, it equals 0. So therefore, perpendicular to 2i plus j minus 4k. And similarly, let's do it now with 3 minus 10 minus 1 dotted with that one, 6, 1 and 8. And we get 18 minus 10 minus 8. Oh, we get 0 again. Therefore, perpendicular to that one. So because that is perpendicular to that directional part and that directional part, it's got to be perpendicular to the plane. So like I said, the alternative is cross those together and get your answer and show that it's some multiple of that. So therefore, that will be another way. Right, what's the next thing? Hence determine a Cartesian equation of pi. Right, well that basically means that that must be the normal vector. So if we've got our two vectors on the plane and we know that this vector is perpendicular to it, that's the normal vector, our n vector. So we know we can write the equation of a plane as r dot n equals a dot n, where n is our normal vector and a is a point on the plane. So it's going to be r dot 3 minus 10 minus 1 is equal to a point on the plane. Well, that's on the line, that point is on the line, so therefore it's on the plane. So is that point on the line, is on that line, so it's also on the plane. So these 2 points are definitely on the plane because they're both on the lines which are on the plane. So I'll take any of these points. Well, obviously that one's got a P in it, so I don't want that. Use that one. I want to use this one. So that's my 1 minus 2, 3. And I'm dotting it with n again. 3 minus 10 minus 1. And that gives me r dot 3 minus 10 minus 1 equals, right, let's quickly do this, 3 plus 20, 23 minus, what's 20? So therefore our Cartesian, don't leave it like that because that will lose you the final mark. Our Cartesian is when we just put x, y and z in, so we're going to get 3x minus 10y minus z equals 20. So you just replace r with x, y, z, and that gives you the Cartesian there. There's our equation. Brilliant. Part C, hence determine the value of P. Right, let's just rub this little bit off first. So, just as I said here, we've got this form, r dot 3 minus 10 minus 1 equals 20. We know that this point here is also on the plane, so that fits this equation, because that's the equation of the plane. So put 5p and minus 7 in there, 5p and minus 7 for our r, because r just stands for any point on the plane, dotted with 3 minus 10 minus 1 equals 20. So let's do that. 15 minus 10p, is that minus 7? Yeah, plus 7 equals 20. Oh, what's p? 22 to, is a fifth? Here's a fifth? Yes, here's a fifth. I haven't done anything wrong there. Lovely. Okay. Oh, did I want to rub that off? No, I've got it up there, that's fine. Okay, so part C. So far not bad really, nothing really too problematic. Right, given that the lines L1 and L2 intersect at the point A, the point B has coordinates 12, minus 11 and 6. Determine to the nearest degree the acute angle between A and B and pi. Okay, so what we do when we're trying to find the angle between a plane and a line, so we're going to have, if I was doing some kind of sketch here, my sketches are not great, so do excuse me. So here's our plane, here's our two lines on the plane that meet there, okay? We are going to have a point B somewhere down here. So that's the point A where they meet. Here's our point B here. We want to find the angle between the plane and AB. And what we do is we find the angle between the plane and the normal instead. And then we just do 180 minus that, or 90 minus that, but we're after the acute angle, so we can deal with that. So we basically find the angle between AB and the normal, and then we can just work out what the relative angle is between the plane and AB, because obviously the normal is at 90 degrees to the plane. So first thing we're going to have to do is find out what A is. So A is where the two lines cross. So what's that? That was a fifth, wasn't it? So we're going to have to equate our coefficients of I, J and K. So for A, where the two lines cross, we're going to work out where these two cross by just looking at the I's, the J's and the K's. I know they intersect, so possibly I might cheat and just use two of these equations in a minute, but let's look at the I's. We've got 1 plus 2 lambda has to equal 5 plus 6 mu. And then for the J's, minus 2 plus lambda has to equal, P is a fifth, isn't it? So a fifth plus mu. Oops, funny looking mu. And then we can do the K's as well. Normally, if we're trying to see if something intersects, we'd have to look at all three equations. The K's would be 3 minus 4 lambda. I'll do this just to see if there's a nicer equation. Equals minus 7 plus 8 mu. Now we're told they intersect, so we could, especially if we're tight for time, we could just abandon the idea of checking with the third one, and we could just take two of these equations, say those top two there, and solve them simultaneously. Well, let's quickly do that. I should be reaching for my simultaneous equation solver on my graphic calculator. Times that by 2, minus 4 plus 2 lambda equals 2/5 plus 2 mu. I'm regretting not reaching for my calculator here. Both 2 lambda, so I can subtract, so I get 5 equals 4 3/5. 23 over 5 plus 4 mu. Oh god, that's horrible. So take that over there. 5 take away 23 over 5 is 2 over 5. Of course, because there's 5 there, isn't that stupid? Equals 4 mu, so mu equals 1/10. Blech. That's not nice, is it? Anyway, so mu equals 1/10, so we can now put mu equals 1/10 into here to find our point. So A is the point. Right, I like to put it in here because it makes it easy. So 5 plus 6 mu, it's all down here. So you can just go, right, 5 plus 6 mu, so 5 plus 6/10, so it's 5, let's just write 5.6, shall we? J's 1/5 plus 1/10, so that's 0.3. And K's there, minus 7 plus 8/10, oh my word, minus 6.2. Wow, it's the kind of answer that makes you think, ooh, have I gone right? Let's just check, shall I? A is 5.6, 0.3 and minus 6.2. Oh, thank you. Right, okay, so back to what we're doing now. We need to find the angle between AB and the normal. So what we're going to do now, I'm going to rub this off here. I've just rubbed off the normal, haven't I? Never mind. I'll look it up again in a minute. So if A is 5.6, 0.3 minus 6.2, and B is the point 12 minus 11.6. So AB is the vector. How do I go from A to B? To go from there to there, I have to add on 6.4. To go from there to there, I've got to take away 11.3. And to go from there to there, I've got to add on 12.2. That does not look nice, does it? Ugh. So I'm now going to dot that with my normal vector. So that's my AB. I'm going to dot it with an N. So I'm going to do 6.4 minus 11.3, 12.2. I'm going to dot it with N. I've forgotten what N is, so I'm going to look back at the answers. N is, oh, it's perpendicular. 3 minus 10 minus 1. Of course it was. 3 minus 10 minus 1. And I know that that is going to be equal to the length of that times the length of that times cosine of theta, where theta is the angle between the normal and AB. So, yeah, I'll just use modulus symbols. 6 minus 11.3, 12.2, 3 minus 10 minus 1. So the length of those two, cos theta. So we're going to dot these together. Way too much. I'm going to cheat here. When you dot them together, apparently you get, dotted with that is 120, apparently. Wow. So that's 120. Length of this one, so we're just going to have to do Pythagoras. I'm going to cheat again, just put that, plus 11.3 squared, plus 12.2 squared, times by the length of this, 3 squared, plus 10 squared, plus 1 squared, cos theta. So we're going to, that's meant to, I tell you, let's put a little bit brackets around that, shall we? So work those out, divide them over, inverse cos, and you get what theta is. And theta turns out to be, you get 40 degrees in the end. So if you do that inverse and you get in the angle between the normal and there is 50 degrees, oh sorry, that's 50 degrees, and therefore the angle between, sorry, the normal and AB is 50 degrees, so the angle between the plane and AB must be 40 degrees, because obviously between the normal and the plane is a right angle, so it's just 90 minus that. So we end up with that theta is 40 degrees. All done. Oh.